So we have seen that we can actually express any binary propositional function using the minterms. And essentially that's a disjunction of conjunctive terms. These conjunctive terms are the minterms, which are expressions that are true only when a certain single input combination is given. Apart from that, they are false. And when you combine them using disjunctions, you obtain what we call disjunctive normal form. And this generalizes to more than two inputs. Suppose we have k logical variables, p1 through p sub k, then we have 2 to the power k minterms. In our specific way, when we dealt with binary functions, we had just 2 logical variables, p1 and p2, and then we had 4 minterms, right? But when you have k logical variables, that will result in 2 to the power k minterms. Again, recall the definition of a minterm. It's an expression which is always false except for one single specific input combination. And we use the subscript, we call that is important in making the computations easy. Minterm 0 is the minterm which is true only when all the input variables are false. So it requires the input to be 0, 0, 0, 0, all the way 0 to be true. M1 requires the input to be the binary number 1. So 0, 0, and the 1 at the end. So it's P1 here, but all the others are negated. Similarly, the final one, in our example, this was M3. And in this case, in the general case, it's M sub 2 to the power k minus 1. And that's the final minterm, and it requires all the inputs to be true. When you have k logical variables, you have in return, you have 2 to the power k minterms. And using those 2 to the power k minterms, you can combine them using disjunctions to express any formula that accepts k inputs. Let's see a very simple example. Suppose that we have 4 logical variables, p1 through p4. Now, if you want to actually write the truth table of all possible logical functions that accept 4 variables, how many are there? Now, first of all, you have to observe 2 to the power 4. There are 16 possible input combinations. And since you have 16 different input combinations, to define a function accepting 4 variables, you have to define either true or false the outcome for each possible 16 input combination. Therefore, you have in total 2 to the power 16 total different logical functions that accept 4 variables. Okay? So writing that table is really going to be difficult. Therefore, we do not do that in the general sense. What we use is the disjunctive normal form. And in this example, let f be the logical function that is true only when the input p4 through p1 is false, 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 true, or false, true, false, false, or true, 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 true. So this means if you actually write the truth table of this function, write p4, p3, p2, p1, okay, and f. Now, I'm not going to write it all the way, but let's say you have, let me use 0, 1, so 0, 0, 0, 1. Be careful about the order here. I'm using p4 as the most significant bit in describing the subscripts. So 0, 0, 0, 1, or 0, 1, 0, 0, and 1, 1, 1, 1. These 3 provide a true output, or rather 1 in my formulation. And all the others, how many others I have? I have 13 other input combinations. They produce a 0. So this is my function. I would like to express this in terms of min terms. So which ones do I need? The min term I require for this one is 0, 0, 0, 1. Obviously, that is M1. And for this one, 0, 1, 0, 0. So I need min term number 4 for this. And finally, with this 1, 1, 1, 1, I need min term number 15. Now recall for binary operators, since we had two inputs, we had 2 to the power 2, 4 min terms, M0 through M3. Here, since we have 4 variables, I have in total 2 to the 4, 16 min terms, M0 through M15. And the function f, as you see, can be written as a disjunction of min terms 1, 4, and 15. Now, this is the generic form. This is the disjunctive normal form. And this here is a simpler expression using the min terms. Now, one final point, the disjunctive normal form is also called sum of products form, because AND operation, in some sense, is similar to multiplication, and OR operation, in some sense, is similar to addition. Therefore, they share some properties. So they are sort of duals or analogs of each other. Therefore, we also call the disjunctive normal form, DNF in short, sum of products form. And in fact, you cannot simplify this expression here by actually dropping the ends, since it's a dual of multiplication, and you just use a plus for the OR. So this becomes this simpler expression. And since this is min term 1, this is min term 4, and this is min term 15, a much simpler representation we use is the sum of products form by using a summation symbol, sigma, and we indicate the number of, or rather the subscripts of the min terms we require to define this function. And in this example, those are min term number 1, min term number 4, and min term number 15.